Welcome to this video. We're going to be talking about the slope of linear functions. So recall that a linear function has two main characteristics. The first is its starting amount, and the second is its constant rate of change. So the constant rate of change is also often referred to as slope, and the slope tells us how fast the output values of a linear function are changing with respect to the input values. So you can think about this in the following example. You've got a walkway to a house versus a steep mountainside. Which pathway changes altitude at a faster rate? The one that changes altitude at a faster rate, that one has a greater slope. So we can clearly see that the steep mountainside would change altitude more quickly as you walk, and therefore it has a steeper or greater slope. So we determine the slope of a function by using two respective input and output values. We can do this because the rate of change is the same for a linear function everywhere. So all we have to do is divide the amount of change in output values per every unit change of input values. We often write it using this notation. y2 minus y1, where those are two respective output values, divided by x2 minus x1, where that's the change in input values for those output values. Divide those two things, and that will be your slope. What about parallel and perpendicular slopes? Two special cases. Well, if two functions have the same slope, we actually call them parallel. And so they would form two lines that look almost identical, except one is at a different starting amount or y-intercept. If two slopes are exactly opposite of each other, and I'll describe what that means, we would call them perpendicular. So exactly opposite means that for the first blue line you have, it's going up A to the right B, meaning the change in input is B and the change in output is A. The exact opposite of that would be the change in input is A and the change in output is negative B, or the opposite of B. So whenever we have two perpendicular slopes, we can prove that they're perpendicular if we multiply them and they equal -1. Let's try some practice questions. So first off, what is the slope of the graph to the right? We're going to start by choosing two lattice points of the graph, and those are points where it crosses nicely, and those will be our input and output values that we need. Remember, you can pick them from anywhere on the graph. So let's just pick those two. So we selected the points -5, 2 and -3, +1. So notice that the change from -5 to -3 is a change +2, and then change from 2 to 1 is down 1 or -1. So our change in input is 2 and our change in output is -1. So we got to divide those things. Our slope will be the change in output divided by the change in input, or -1 divided by 2. Okay, what if we're just given 2 points? Determine the slope of the line that passes through 114 and 95. So we're going to do the same thing. First, we'll determine the change in output values. In this case, 14 to 5, that's -9. And then we determine the change in input values. From 1 to 9, well, that's a change in +8. Divide the change in output by the change in input, and you get -9 divided by 8. Last example, let's find the slope of a line perpendicular to this one, which has a slope of 7/2. So we can see that, well, first we got to remember the slope that is perpendicular is going to be exactly the opposite. So we see that the output change is 7, +7, and the input change is 2. So let's flip those things and make one of them negative. So the opposite of that would be for it to change by -2 and the input to change by 7. So we can rewrite this as -2/7. So in effect, you're really just flipping the numbers and changing the sign. So if it was originally negative, you change it positive, and vice versa. All right, and that's it for this video. So go ahead now and try some practice on your own.